motion, equation of motion. So what is the use of equation of motion? Equation of motion. So basically, when on an object many forces are acting together, then we will draw a free body diagram on which we are going to depict all the forces, whatever forces are acting. For example, suppose if you are having a block like this, okay, it is possible that its weight is acting downward. Normal reaction will be here. It is possible that one of the force is acting in this direction. Another force is acting in this direction, that is F2. Some another force is acting in this direction. So many forces are acting on it. Okay? So what we are going to do, we will draw a free body diagram on this. We will depict all the forces which are acting, and then due to these all forces, due to all of these forces, basically there will be an acceleration that will be produced in this body. So there will be these forces, they are the cause, and what will be the result? Result will be the acceleration. So what will be the acceleration that is caused? That is given by the equation of motion. So mass into acceleration, acceleration produced in this body due to the application of all these forces. Due to the application of all these forces. So by applying all these forces on this block, there will be some, I don't know in which direction, but I'm writing here. Suppose an acceleration A is produced. Then this cause and consequence relation between the force and the acceleration, it is represented by the equation of motion. So this is the source or cause, and this is the result. So this is causing an acceleration in the object on which these forces are acting here. So this is called as equation of motion. Equation of motion. It is always advisable that resolve all these forces in three mutually perpendicular direction. One direction you are going to choose x, y, and z direction. So basically what you are going to do, resolve this equation into three equations along x direction, along y direction, along z direction. So in x direction, it will be max, that will be equal to the x component of all these forces. So this will be f xi. Second, in y direction, this will be may. This will be sigma. This will be fyi. These are the y component of all these forces. Maz. Acceleration in the z direction, this will be sigma I f zi. So basically, here we have resolved this equation into three different equations, and it is always easy to solve these three equations. And by finding ax, ay, az, we can write that, okay, final acceleration is like this. This will be ax I cap plus ay j cap plus az k cap. So with the help of this equation of motion, one can find out the acceleration that is caused by the forces acting on an object. So this is called as equation of motion. This is called equation of motion. Now, for example, here, please note it down quickly. Please note it down quickly. So, first example here is, suppose you are having an object. This is a smooth surface. This is a block of mass m, and I am applying a force F on this object at an angle theta with the horizontal. This is theta. Now you have to find out the acceleration due to this force. Acceleration due to this force that is exhibited by this block. So what will be the acceleration of this block if a force F at an angle theta with the horizontal is applied on it? So what you are going to do, you will resolve. So you will resolve this F into two component. In this direction, it will be F cos theta. In the perpendicular direction, it will be F sin theta. This will be F sin theta. If you look at its weight is going to act in the downward direction. So we have to depict all the forces which are acting on it. So that will be mg. And because this block is in contact with the ground, so a normal reaction is going to act in the upward direction. So this will be n. So this block, it is not going to move up or down. It means force components in the upward direction, they are balanced by the downward direction. So basically this block, it is going to move in this direction. I am saying its acceleration is in this direction. So we are saying this block is having contact with the ground surface. It continue to have its contact with the ground surface, means it is not moving up or down direction. So I can write first equation, upward forces and normal reaction plus this F sin theta, that will be equal to mg. So if someone asks you to calculate the normal reaction, then normal reaction will be mg minus F sin theta. Sin theta. And acceleration in this direction to the right, it will be caused by this component. In this direction, only one component is acting, that is F cos theta. So basically this F cos theta, this is causing acceleration along the x-axis, you can say, and that will be, suppose mass of this block is m, and this acceleration will be a. So what will be the acceleration in this case? That will be F cos theta divided by m. So this will be the acceleration that is exhibited by this block, ठीक है ना? By this block, if a force F is acting on it at an angle theta with the horizontal. Here, I'm assuming this is a smooth surface. ठीक है ना? We are considering it a smooth surface. We are neglecting friction right now. This is one. ठीक है? This was the first example. Second, please note it down quickly. Next, suppose next example, example 2. This is example 2. Suppose 3 blocks are placed on the surface. So this is first block, M1. Its mass is M1. M1. It is in contact with the second block, that is M2. And third block is there, and its mass is M3. Now you apply a force from this side. Suppose force F is applied from this side. Then what will be the normal reaction between these surfaces? Here, this first block and second block, they are in contact with each other. So they are exerting normal reactions on each other. Similarly, block 2 and 3, they are in contact with each other. So they are going to apply normal reactions on each other. So first you have to find out those normal reactions. Second, this block is having these 3 blocks together. They are going to move as a result of this force applied, and their acceleration is suppose A. So you have to find out the acceleration. You have to find out the normal reaction that is acting between these blocks. So how you are going to solve this? So in between first and second block, this first block is exerting a normal reaction here, that will be N1. And on the first, this will be N2. Sorry, N1. This will be also N1. So they are, one is applying a normal reaction on the second, and second is applying the same but opposite reaction on it. You can say they are action and reactions here. Similarly here, second is exerting a normal reaction on the second N2, and it is exerting this N2. Third is exerting a normal reaction on second block of mass M2. So these are the forces which are acting. This force F is acting on this. So you are going to draw here a free body diagram for the first block. I'm saying this is first block. If you look at, then on this block, try to understand force F is acting from this side. From this side, normal reaction N1 is acting. N1 is acting. Its weight, you can say mg m1g, that is acting downward, and you can say normal reaction here, this surface is in contact with the ground, so this will be r1. So r1 is going to balance this m1g here. We are not interested right now in this. So look at here, in this direction force F is acting, N1 is opposing on it, and what is the acceleration? All the three blocks, they are moving together. So acceleration of all the three blocks will be same. We are assuming that acceleration is A. So this will be the acceleration. So F minus N1. F1 is the force. F1 is the force that is causing acceleration. Who is opposing part of the opposing part, or I should write here. This is F1 that is causing acceleration. This N1 is opposing this motion, so this will be N1 here. And resultant of this is responsible for the acceleration in M1, block M1. So this will be my first equation. ठीक है? And it is F actually only. This will be. Now, draw the free body diagram for the second one. Forces which are acting on the second block. So look here, N1 is acting in this direction. This is N1 that is acting. From this side, N2 is acting on it. N2. ठीक है? Mg is acting in the downward direction, M2g. Normal reaction is R2. So this R2 here, R2, it is going to balance its weight, M2g. And for acceleration, N1, this block, in which direction it is moving in this direction. All the three blocks, they are moving in the same direction. So acceleration of this block is A. So I can write this equation as M2A. And who is causing this acceleration? This N1 to the right, and opposing force, that is N2. This is the second equation. So in this way, you have written the second equation. Now for the third, if you look at the third block, its weight M3G is acting in the downward direction. This is in contact with the ground. So in the upward direction, R3 is going to act. So R3, that is going to balance this M3G. And in the horizontal direction, only one force is acting, that is N2. And this is causing an acceleration A in this direction. So what it will be? This will be, acceleration will be A in the mass M3. And who is causing this? That is N2. So from here, first with the help of these free body diagrams, you have written three equations. Okay, these are three equations, and we have written according to equation of motion. Now, if you add all the three equations, what is going to happen? If you will add, this N1 will cancel out by this N1, this N2 will cancel out by this N2, and on the right hand side, we will have F only. So on adding 1, 2, and 3, what you are going to have on the right hand side, that will be F. If you are adding left hand side, then you are going to have M1 plus M2 plus M3 into A. This will be. So what will be the acceleration? Acceleration is equal to F upon m1 plus m2 plus m3. Directly, I have just explained you how to write these equation. Otherwise, you can observe directly. Net internal forces will be zero. Only one external force is acting, that is F. So this F is causing an acceleration in all the three. So even directly, you can write m1 plus m2 plus m3 into A. That will be equal to F. ठीक है, but we have to learn how to write these equations. So this is the acceleration there with which these three blocks together they are going to move. Now, what will be N2? Normal reaction. N2. Look here, N2 is equal to M3A. So M3, here it will be M3, and acceleration A will be F upon M1 plus M2 plus M3. M3. This will be N2. What will be N1? ठीक है, N1, for N1 you can write from here, N1 will be M2A plus N2. So what will be N1? N1 will be N2 plus M3A. M3A. So now look, what is N2? N2 is M3, sorry, this will be M2A here. This will be M2A. M2A from here. And N2 is M3A. So if I write M3A here plus M2A, so N1 will be M2 plus M3. M2 plus M3. And what will be the acceleration? Acceleration is this. So this will be F upon M1 plus M2 plus M3. This will be N1. So in this way, one can find out N1, N2 and acceleration for this problem. This is the first one. Another example, second example. This was. Is it clear?
Yes, sir.
Good. Next. Suppose this is example 3 here. Example 3. Or you are having this type of one pulley is here. Fixed pulley, massless pulley is there. And what you are going to have? You are going to have a mass M1. This is a mass M1. Here there is another mass M2. ठीक है? One of these string is attaching these M1 and M2 block. This is M1. This is M2. So I write it as M1. It is of mass M2. And a string is attached with this M2 that is passing over this pulley. And its another end is attached with a block of mass M3. This is M3. M3. ठीक है? Now you have to find out the acceleration of M3, M2 and M1. ठीक है? You have to find out the acceleration of this system. So what you have to do, you are assuming that this block is moving in the downward direction. Some of the student may say that suppose it is moving in the upward direction. Okay, no problem. In that case, acceleration will be negative. Whatever calculation you are going to do, after calculation, you will find out that this acceleration is negative. If acceleration is coming out negative, it means whatever is your choice, opposite to that opposite to that will be the acceleration. Suppose acceleration is coming out to be positive, then your choice is correct. So in this way, there is no need to worry about the direction because plus and minus sign, they will tell you, okay, your choice is correct or you have just assumed in the opposite direction. So because they are attached, all the three blocks, they are attached with inextensible strings. So due to that reason, acceleration of M2 will be A, as well as acceleration of M1 will be A. So they all the three blocks, they are going to move with the same acceleration. Now, now depict the all the forces which are acting here. So on this block, M3 block, M3G, its weight is acting in the downward direction. Tension on this is pulling effect. So tension will be in the upward direction. I'm calling it as T2. Tension T2 is acting on it. Because this string is same, so there is a tension here and that will also have a pulling effect and T2 tension will be there. This is a different string. So on the M2 block, tension will be in this direction. On M1, tension will be in this direction. And I'm assuming they are T1 and T1. T1. If you look at their masses, mass of this M1 block, it is acting in the downward direction, M2, M1G. That is M1G. Normal reaction is there, R1. M2G, that is acting in the downward direction. And normal reaction is here, that is R2. So this is the situation. ठीक है ना? So this is the situation. All the forces I have shown here. So try to understand first this one, M3. In which direction this block is moving, we are assuming, we are saying acceleration is in the downward direction. If net acceleration in the downward direction, so automatically M3G should be greater than T2. ठीक है? So only then this downward acceleration will be there. So I will write this as M3 into acceleration. This is the acceleration of this block 3 and who is causing M3G in the downward direction. This is the direction of acceleration minus the opposing force, that is T2. This will be my first equation. For this R1 is balanced by its weight, or weight is balanced by the normal reaction. This is R2. Similarly, this weight M1G of the first block, this is balanced by the normal reaction R1. R1. So due to this region, they are not moving up and down here. So who is causing the acceleration in mass M2? That is T2. T2 is in the same direction as of the acceleration. So this will be mass M2 into A. So who is causing acceleration? T2. And the opposing force, if you look, that T1 is opposing this motion. So net force that is responsible for the this acceleration A for the second block will be T2 minus T1. Okay? For this block, it is having acceleration to the right. Towards right, only one force is acting, that is T1. So T1 is causing this acceleration. So that is T1. It is causing an acceleration in block 1. Block 1. If you add all the three equations, then T2 will cancel out, T1 will cancel out on the right side. So on the right side, what you are going to have, you will have M3G. M3G. On the left hand side, it will be M1 plus M2 plus M3 into A. So what will be the net acceleration? Net acceleration will be M3G divided by M1 plus M2 plus M3. This will be the net acceleration. All the three bodies, they are moving with the same acceleration. M3 is moving in the downward direction. M1 and M2, they are moving towards right. They are moving towards right. So this will be the acceleration. So here our natural choice of acceleration was okay, but sometimes you will have a situation that both type of motion will be possible. In this question, upward motion is not there. That is not possible. But so you know that it is in the downward, so this is my natural choice. But suppose there may be a situation where you will face a situation where this block can move in the downward or upward. So then don't worry about the direction. Don't worry. Just assume one direction And in this direction, suppose this is the chosen direction, choose the acceleration and draw all the forces, solve the problem. If you are getting acceleration positive, then your choice of the direction of the acceleration is correct. If you are getting negative value, it means your choice was actual acceleration is opposite to your choice. Okay, so that type of situation will be there. If you
सर
want to find, yes, beta, please.
सर इसका मतलब ये हुआ कि एक्सेलरेशन इज इक्वल टू ड्राइविंग फोर्स डिवाइडेड बाय टोटल मास.
Uh, Here in this case, yes, yes, in according to equation of motion, this is the situation. On the right hand side, whatever forces are acting in a particular direction, those forces they are going to cause the acceleration in that particular direction. ठीक है ना? But situations may be different, angles may come into the picture, so every time directly you cannot write like this. ठीक है? So these are simple problems, starting problems, so you can write directly even also. Without solving the problem, just by observing, you can directly write the result. But when angles starts coming into the picture and friction force will be there, then situation will become uh, a little bit complicated, you can say. So this is now come to the next. Suppose you are having this is example 3. This is a very simple example. Suppose you are having an inclined plane, and some block is going to move in the downward direction. Suppose you place a block here. ठीक है ना? You place a block here, then what will be the acceleration of this is a smooth. I'm saying this is a smooth surface. Inclined surface is smooth. Then what will be the acceleration of this block? This is the one of the simplest problem. So suppose this angle is theta. ठीक है? Wedge angle. So its weight is going to act in the downward direction. Mg. In the last class I discussed, if this angle is theta, then this angle will also be theta, because here this angle will be 90 minus theta, this angle will be theta. So this will be mg cos theta. This is one component of the weight that is acting perpendicular to this inclined surface. If you look at here, this block is in contact with this inclined surface, so a normal reaction will be there. And a component of this mg will be parallel in the downward direction, parallel to the inclined surface. This will be mg sine theta. And suppose acceleration of this block in this direction is a, and we are assuming this surface is smooth. So what will be the acceleration? Try to understand, this block is not moving in the upward direction. So it means this normal reaction and this mg cos theta, they are balancing each other. So first equation you are going to write, that will be n is balancing this component mg cos theta. Then only one unbalanced force is there which may cause acceleration in the downward direction, that is mg sine theta. So who is causing acceleration? Mg sine theta. And it is causing acceleration in the mass m. So this will be mass m into a. So this will be a equal to g sine theta. This will be g sine theta. So this will be the acceleration in this case. This is this is the simplest case of the inclined plane. ठीक है? We generally start from here. Is it clear up to this point?
Yes, sir.
Good. Next. You are having a booklet with you of mechanics. Do you have that booklet?
Yes, sir.
So now try to solve the questions of Newton's laws of motion. What you have to do is start solving the questions of first chapter, Newton's laws of motion. ठीक है? So please try those questions and I will discuss. ठीक है ना? I am going to discuss your doubts as well as some of the questions which I think are good for your exam. So next question is this. Suppose you are having an inclined plane like this. Here you are having a pulley, massless pulley. A block is here. You're having a block here. You call it as M1. Its mass is M1. Okay? It is attached with a string that is passing over this pulley. And another end of this pulley, it is attached with another mass, M2. Its mass is M2. M2. This angle is theta. Now you have to tell me what will be the acceleration of this system. What will the acceleration of mass M1 and M2? M1 and M2. You are going to find out. So first, for this purpose, you have to draw all the forces on this M3. First, I am assuming that M2 is moving in the downward direction. This is my choice. It may be opposite also, depending upon the masses of M1 and M2. So weight of it is acting in the downward direction. That will be M2G. A tension force T is acting in the upward direction. So acceleration, because I am assuming in the downward direction. So my equation will be acceleration is caused in the block of mass M2. So M2A, that will be in which direction force would be more, so that net acceleration is in the downward direction. So this M2G should be more as compared to T, only then it will move in the downward direction. So this will be M2G minus T. T is in the opposite direction. This is the first equation. Next, on this block mass M1, tension is acting in this direction. That is okay. Its weight M1G, that is acting in the downward direction. If you make a component of this perpendicular to the inclined surface, then this angle is theta and component will be mg cos theta. A component will be here in the opposite direction. That will be, this is M1. This will be M1G sine theta. Normal reaction, because this block is in contact with this inclined surface. So inclined surface is going to exert a normal reaction N. So this N will balance M1G. So I'm going to write N is equal to M1G cos theta. If this block is moving downward with acceleration A, automatically acceleration of M1 will be in this direction. It will move upward with the same acceleration because this string is inextensible. Its length is not changing. So if this block is going to move, so only by the same length, it will move in the upward direction. So whatever acceleration will be here, same acceleration this block is going to have in the upward direction. So it will be like this. What will be the equation for this acceleration? Acceleration in the block of mass M1. So this will be M1 into A. This is the acceleration that is caused. Who is causing acceleration? This tension T. And who is opposing this motion? This M1G sine theta. It is in opposite direction. So this is M1G sine theta. So add these two equations. Now add these two equations, so tension will cancel out. So this will become M1 plus M2 into G into A. And that will be equal to M2, M2G. Okay. This will be minus M1G sine theta. So M1 sine theta. G is common. Okay. So I will write G here. This will be M2 minus M1 sine theta. So what will be the acceleration? Acceleration will be M2 minus M1 sine theta divided by M2 plus M1. And that will be G. This will be the net acceleration. Look here, if M2, try to understand, there may be two cases. If this M2 is greater than M1 sine theta, if M1 this M2 is greater than this M1 sine theta, then this acceleration will be positive. A will come out to be positive. It means block is moving in the downward direction as we have assumed. So block will move in the downward direction. Block will move in downward direction. In downward direction. ठीक है? Suppose M2 is less as compared to M1 sine theta, then if M2 is less M1 sine theta, then this acceleration will be negative. Then our choice was opposite. So it means acceleration will be in the upward direction, block will move in the upward direction. So our choice was opposite. So block will move in the upward direction. In upward direction. This will be the case. So in this case, block is going to move in the upward direction. ठीक है? In this way, you are going to try to solve the questions. Next. Lift problem. Lift problem. ठीक है ना? Before lift problem, suppose this is the ground surface. Before discussing this lift problem, I'm going to tell you one thing. Suppose this is ground floor, and here you place a weighing machine. What is this? This is weighing machine. This is a weighing machine. What is this? This is weighing machine. Weighing machine. Now, try to understand. Suppose a person is standing on this. A person is standing on this weighing machine. Then what will be the reading of this? What will be the reading of this weighing machine? What reading it will read? ठीक है ना? Try to understand. So, look here. The mass of this person is acting on the downward direction. This person and this person and this part, they are in contact. This person and this weighing machine, they are in contact. So this weighing machine, this is going to exert a normal reaction in the upward direction. So this will be N. They are going to balance each other. They are going to balance each other. Now, this person is going to apply a normal reaction on it. So what this person who is standing on it, it is going to exert a normal reaction. ठीक है ना? It is going to exert a normal reaction on this. So try to understand on this how this weighing machine is going to observe this person. This weighing machine is going to observe this person by this normal reaction. So what will be the reading of this? Reading of weighing machine. Reading of weighing machine is equal to normal reaction. Reading of weighing machine is equal to the normal reaction. This will be. So remember this. Whatever reading you are going to observe in a weighing machine, that will be equal to the normal reaction. This person is going to exert on this, or this weighing machine is going to exert on the person. So whatever reading this machine is going to give us, that is actually the normal reaction N. So always keep in your mind this aspect. ठीक है? Through in all type of problems related to weighing machine, you have to understand this aspect. So what will be the reading machine? Reading machine is going to measure or going to read actually normal reaction. So whatever will be the normal reaction, that will be the weight you are going to observe in the weighing machine. This is now come back to this lift problem. Come back to the lift problem. Now, look here. There is a lift. One by one, I'm going to give you all the cases. This is a lift here, and it is, suppose it is at rest. So first case may be that it is at rest. And here there is a weighing machine. ठीक है ना? Weighing machine. So here, this person is standing here. So what this is going to read? It will read, ठीक है ना? Normal reaction. ठीक है ना? It is going to read normal reaction here. So apparent weight, you can write here, apparent weight that is an normal reaction when the person is in the lift, it will be equal to mg, or that is actual weight is equal to actual weight. Or I should write another way. Just 1 second. I should write like this, that normal reaction in this case that will be equal to mg. ठीक है? Because the weight of this person is acting downward mg, and this lift is going to exert the normal reaction n. So because lift is at rest, so n is going to balance mg. So n will be mg. So this is the reading that this weighing machine is going to read. So apparent weight is actually the actual weight in this case. Actual weight. So there is no problem here. Lift is at rest. This is a very normal situation as we observe on the earth. This machine is going to give the actual weight. Now, second, ठीक है? Second case. Now suppose this lift is moving with a constant velocity in the downward or upward direction. Second case is, this is case 2. This is case 2. This was case 1. So here V is constant. If V is constant, then what will be the acceleration? Acceleration will be 0. So acceleration will be 0. Here you are going to have weighing machine. What will be the weight that you are going to observe in the weighing machine here? Person is standing. ठीक है? So its weight is acting downward, and here normal reaction is this. So weight is acting downward and normal reaction is there, but acceleration is 0. So what will be your equation here? You can write that this mg minus normal reaction, and they are not causing any acceleration. These two forces are acting, but acceleration is 0. So you can write m into acceleration is 0. So here n is still equal to mg. Mg is the actual weight. So apparent weight is equal to actual weight. Actual weight in this case. So this was the second. So in these two cases, whatever weight you are going to observe in the weighing machine on the earth, same weight you are going to observe here. Because acceleration in both cases is 0. If it is at rest, acceleration is 0. But things changes if this lift start moving in the downward or upward direction with some acceleration. Case 3. Case 3. Suppose lift is moving downward Suppose lift is moving downward with some acceleration. I'm saying that this is acceleration A. This lift is moving in the downward direction with an acceleration A. So this is a weighing machine here. This is weighing machine. Person is standing here. On this person, its weight is acting downward. And this weighing machine is exerting a normal reaction in the upward direction. Now, on this person, two forces are acting. One is in upward, another is in downward. And what is in which direction this person is moving? It is moving with the lift. It is moving in the downward direction with an acceleration A. When lift is having acceleration in the downward direction, so automatically this person is also having acceleration in the downward direction. What is the acceleration? That is A. So, due to these forces, who are responsible, which are taking this person in the downward direction with an acceleration A, that is downward force. So, you can write that mg, that is acting in the downward direction, minus upward direction force, opposing force. Motion is in downward direction. M is the mass of the person, so this will be ma. Ma. So overall person is moving in the downward direction with an acceleration A with the lift. Only two forces are acting on it. One is normal reaction in upward, its weight is downward, and it is moving in downward. So mg is leading force in the downward direction along the A, minus n is opposing force. So mg minus n, it will be ma. So what will be the normal reaction that this weighing machine is going to read? That will be mg. Bring this ma on this side, so this will be mg minus a. So this will be, and it is less than mg. This is what? This is the apparent weight that is readed, ठीक है ना? That is readed by this weighing machine. Weighing machine is going to read this weight only. So apparent weight in this case of this person, apparent weight of this person will be less than actual weight. Will be less than actual weight. Remember this. Will be less than actual weight. Now suppose, ठीक है, even in this case, special case is there. Special case. If you cut the string of this lift, if I cut this string, ठीक है, if rope of lift is cut, then lift will undergo free fall. Lift will fall with acceleration, with acceleration a equal to g in downward direction. In downward direction. This is also known as free fall. ठीक है? You also call it as free fall. Free fall. This will be. So what will be n here? So this will be m. This will be g minus a. So this will become g minus g. And that will be 0. So what will be the reading of the machine? N. That will be 0. So apparent weight here is 0. And this is the situation of weightlessness. This is the situation of weightlessness. Weightlessness. This is the situation of weightlessness. Okay. Next. Another special case is there. Suppose this is our Earth and a satellite is here. I'm just showing it a little bit greater. It is undergoing this type of circular orbit. Circular orbit. Okay? Then try to understand. Basically, it is undergoing circular motion. If the satellite is undergoing circular motion around the Earth, then who is going to provide the centripetal acceleration? Centripetal acceleration or centripetal force is needed. So who is going to act as the source of centripetal force? mv square upon r. ठीक है ना? That will be the gravitational attraction between the satellite and the Earth. So this will be gm, mass of the Earth. This is the mass of the satellite. So this is mass of the satellite upon, this will be r square. So this ms is going to cancel out and this is v square upon r and this will be gm upon r square. What is this called? This is called as centripetal acceleration that is acting toward the center of the Earth, and this is equal to g at this height, whatever height is this. ठीक है ना? Height of this from here, from the surface. So we write it as gh. I'm writing it as gh. So try to understand, if a person is inside this satellite, if a person is inside this satellite, then try to understand it is having an acceleration AC towards the center of the Earth. Towards the center of the Earth. So this is one thing. Second, person in this satellite is attracted by the Earth by the same G. So it's weight of the person. This person is attracted by the Earth. Try to understand. This person is attracted by the Earth by a force, you call it as weight. So what is the natural weight? It's weight mgh, you can say, that is acting here. So if you are having a weighing machine here, if you place a weighing machine here in the satellite, then what will be the normal reaction? Normal reaction will be mass of this person, ठीक है, g, with which Earth is attracting this person towards its center, minus acceleration. This person is also going to have an acceleration AC here. This satellites, you can compare this satellite with the lift. So what is the acceleration of this lift or this satellite? That is AC toward the center. So this will be your formula. ठीक है ना? So this is the normal reaction that this lift, that this weighing machine is going to exert on this person, and this is the reading of the lift in the satellite. That will be m gh. Gh is the gravitational acceleration that is acting on this person in the satellite here. This is the value of gh here at the position of the satellite. Second, this person or this lift, I'm not saying this is not a lift, this is a satellite. If you compare with the earlier problem, this is acting like a lift. And what is its acceleration in the downward direction? That is AC. So write the same formula mgh minus AC. Now, how much is AC? AC, from here you can observe that is GH. So you can write M GH in place of AC, write GH. So GH minus GH, that will be 0. So normal reaction will be 0. So apparent weight in the satellite will be 0. So that's why a person in the satellite, he is going to observe the condition of weightlessness. So this is a weightlessness condition. Weightlessness condition. That is observed by a person in the satellite. That is observed by the person in the satellite. So this was the third case. This was the third case. Now come to the fourth case. If lift is moving in the upward direction. If lift is moving in the upward direction. Fourth case. If lift is moving in the upward direction with an acceleration A, weighing machine is here. You want to measure the apparent weight that will be read by this weighing machine. So person is standing here. So weight of this person is acting in the downward direction. mg. Normal reaction this person is going to observe by this weighing machine will be n. So now overall this person is moving in the upward direction because lift is moving in the upward direction. So acceleration of the person is in upward direction. Ma, who is causing it? Upward force. Upward force is normal n reaction. And who is opposing force now? Weight is in downward direction. So this is opposing force. mg. So what is normal reaction? Normal reaction is mass A plus G. This will be normal reaction. That is normal reaction. Normal reaction is M A plus G. ठीक है? M A plus G. So in this case, apparent weight is greater than actual weight mg. Actual weight is mg. Actual weight mg. This was the fourth case. ठीक है? That is the fourth case. There may be one more case. They sometimes they can ask. That will be the last. This will be fourth and fifth. Suppose lift is retarded lift is if lift is having retarded motion, retardation in the downward direction. In the downward direction. So basically, what you are saying, lift is moving in the downward direction, but its acceleration is negative. So here, this is weighing machine. Person is standing here. It is having a retardation here. So what is acceleration here? Acceleration is minus whatever retardation is here, AR. It is. So I'm writing minus because this in this question it is given that it is retarded in the downward direction. And what will be the normal reaction if A is in the downward direction? Normal reaction. That will be M. ठीक है? If you look at these cases in the first, this one, if lift is moving in the downward direction with the acceleration, this will be n equal to mg minus a. This will be m g minus a. M g minus a. G minus a. But a is equal to, because of retardation, this is minus ar. So place here minus ar. So what will be normal reaction? That will be m g. It will be like this, that for example, like 2 meter per second square. It will be like this. So here this AR will be a number. So minus minus plus, this will be AR. So this will be 9.8 plus 2. It will be like this. So in this case, this apparent weight is greater than the actual weight. Actual weight. Now you can try, ठीक है, some of the questions from your booklet. ठीक है ना, which are based on Newton's laws of motion as well as on equation of motion. I will discuss those questions also. So in the next class, first I am going to discuss friction force. And after completing friction force, it will take one class. In the first class, I will discuss friction force. And then in the second class, I will start discussing numericals from all sections, whatever I have discussed up to this point. Okay, beta. Thank
सर
you very much. Yes, beta, please.
सर ये न्यूटोनियन मैकेनिक्स और फ्लूइड मैकेनिक्स को कंप्लीट होने के लिए और कितने लेक्चर्स लगेंगे या आवर्स में बता दीजिए।
But I will try as much as quick possible. ठीक है, exactly तो नहीं बता सकता, but I will try to do as much as possible, as fast as possible. ठीक है,
फिर
अभी
भी सर opportunity
after this I will try to tell you. After this, we have this chapter, work energy. I'm going to tell you. ठीक है, and power. Then I have to discuss collision problem here. ठीक है, collision problem. After collision problem, I will discuss center of mass. ठीक है, and then rotational mechanics. Moment of inertia, etc. I have already discussed. So rotational mechanics, या rotational motion or dynamics. So you can consider for the theory part, I need 2 lectures here, 1 lecture here, and I think maximally 2 lecture here. ठीक है, and if I look at friction tomorrow's, this part also, 1 lecture. So these are the theory part, theory related lectures, 2 to 4 plus 2, 6. I need 6 lectures for theory part, and rest 7, 8 classes I will take for numerical parts. ठीक है, 7, 8 classes for numerical. So this will be 12, 15 classes roughly, beta. 15 lectures, 15, 16, so means 15 lecture means you can consider 15, 16 hours I need. ठीक है, so it will be like this. ठीक है, so 15 lectures you can assume. Is it okay? Or any another question? Tomorrow I will discuss friction, as well as in second lecture I will discuss numericals related to 1D. ठीक है, so I will complete that part. In the next, I will discuss the questions of projectile motion. ठीक है, projectile motion, and then circular motion I have already discussed. You can look into videos. And then questions of friction, Newton's laws of motion, work energy, collision. So it will be around 15 lectures roughly.
सर फ्लूइड मैकेनिक्स का अलग से होगा क्या सर।
हाँ, fluid mechanics I will take. For fluid mechanics, I can tell you 2 plus 2, 2 lectures for the theory part, not less than this, 2 lectures, plus 2 lectures for numericals, 4 hours. ठीक है ना, lecture means 1 hour, roughly 1 hour. So 19 or 20 classes if you consider fluids also. ठीक है ना, so they will be like, I will try to take lengthier classes or 2 classes per day. So in that way I will try to complete it as quickly as possible. चलिए बेटा, ओके बेटा,
गुड नाइट सर।
गुड नाइट
Thank
बेटा,
you, sir.
वेलकम
Thank you,
बेटा,
sir.
वेलकम
थैंक
बेटा,
यू।
वेलकम।